All right. Hey, folks. Welcome. Brian Redmond here. Thanks for joining for another AKS community recording. For those that don't know me, my name is Brian Redmond. I'm a product manager on the AKS and Cloud Native Platforms team. And we have an interesting topic here on Azure Linux for AKS. Hopefully people are aware of Azure Linux, but we really want to kind of dig in and talk about where it fits into your AKS environments. So I have special guest Sudanva here. We've worked together for quite some time. How about introduce yourself? Tell us the team you work on, what you do, and maybe something interesting that most people don't know about you.
Oh, hey everyone, my name's Sedonwa. Thanks, Brian, for having me. I'm a product manager at Microsoft, been here for almost 7 years. I work on the Azure Linux team and specifically on the Azure Linux integration with AKS, both on the edge and in the cloud. Something that people don't know about me, so I am Canadian. That's probably not crazy news, but I am also a Toronto Maple Leafs fan. And since I've been born, they have not won a single Stanley Cup, which is something that you may not know about me or the Maple Leafs, which I fondly love. So that's a little something about me, Brian.
Awkward. That's a little sad. I spent most of my life in Pittsburgh in Pennsylvania.
Oh
The
man.
Penguins have a long history of Stanley Cups, but sorry.
Yeah, very jealous of you guys in Crosby and all the cups you won in the last few years.
Painful for a lot of teams. But yeah, I will say too, just one thing that comes to mind when we start this, like I think there's a lot of people who may not be paying attention super close to Microsoft's contributions in the open source space. There's probably some companies that would have thought Azure Linux would never be a thing, that Microsoft would never have a Linux distribution. Personally, in my view, I wondered why it took us so long. But just off the top of your head, like, why did we do this in the first place? I know you might cover this later, but that's the first question that comes to mind.
Yeah, we started off with this project looking to solve a problem for our internal services. What people may not know is that a huge swath of internal Microsoft services across the company actually run on Linux. And as we look to build on platforms that we can guarantee security from, we needed to build a Linux distribution to guarantee that supply chain security of all the binaries of all the services that we run on. So we started this project, I think it was 3 to 4 years ago, and those were the initial motivations, and then we took it to market, via AKS last year, because hey, we realized a lot of our customers need and want a lot of the same benefits that we offer for our internal services. So that's a little bit about why we decided to build a Linux distribution on Microsoft.
Yeah, awesome. I'm really glad that it's here. One of the things I hate when we do these is the presentations often start with someone goes right into some slides, and it's really like high level. Here's where we started, and it takes about 20 minutes to get to the fun demo part.
Yep,
How about just start with the demo right out of the gate? Does that sound good?
it does. In Microsoft fashion, I actually did have slides. So we'll pass on those, and I'll get straight into the demo. And let's
Awesome.
switch to that. Want to set a little bit of context here. Azure Linux is available as a node operating system for your AKS cluster. So folks may be familiar with Windows support. We have today Ubuntu, and Azure Linux is another option. Deploying Azure Linux clusters is really as simple as going into your infrastructure as code template files. So in this case, I've chosen Bicep, but there's no reason you can't use ARM. We support Terraform, we support Pulumi. And I want to highlight uh, where and what you change to get started with Azure Linux. So in this Bicep template, I have agent pool profile. So this is an AKS resource that I'm defining. In this case, it's a system node pool. But Azure Linux is going to be specified in the OS Sku parameter. So as part of your agent pool profiles, you're going to add an OS Sku property, and you're going to specify Azure Linux to deploy Azure Linux node pools. Now, you'll hear me talking about node pools being Azure Linux and not clusters, because when I switch over to my other screen, you can actually have mixed node pool clusters. So in this demo example, if I do a kubectl get nodes in Azure, I have a cluster that's already deployed, and it has 6 nodes, 2 node pools, and you'll see that 3 of them are running CBL Mariner, and 3 of them are running Ubuntu. I also want to use this time to call out some of the differences in the two that you may see. You'll see the kernel versions are the same. We are also using containerd just like Ubuntu is using containerd. And one of the concerns that customers often bring up when we talk about a different OS is, oh my God, I'm going to have to rewrite my applications to run on this other distribution. What I want to show you in this demo is how seamless it is to use distributions as you wish. So in this example, I've cordoned off the Azure Linux nodes. So all of the pods have been scheduled on the Ubuntu nodes. So if I take a look at the pods that I do have running, and this is actually a demo that Brian's created, it's the storefront application. There's a set of pods that are running on the Ubuntu node pools. So if I go back here, I do kubectl get service. There's the external IP for the store admin and the storefront application. Now, if I pull open my browser, you can see that it's fully functioning. I can hit the storefront application, go to products. I can do the store admin. I can add products. I can check out what orders have been placed. Now, if I want to move these over to Azure Linux, there's actually no rewrite of the application, no rebuild of the containers. All I need to do is first I'm going to cordon off the Ubuntu nodes. So there's nothing that gets scheduled by the scheduler on that. Next, I'm going to uncordon the Azure Linux node pools, and then I'm just going to drain everything on the Ubuntu nodes. And what this does, obviously, is it will take all of those pods that have been scheduled on the Ubuntu nodes. You'll see them terminating as they're draining from those node pools and restarting on the Azure Linux. And once they all get rescheduled, that same application that you built and deployed will just run seamlessly on Azure Linux. And the reason why that's the case is, as I showed you on the previous terminal, it's just Linux. We're just taking the upstream Linux kernel. We're taking containerd, although we're using 1.6 and the Ubuntu versions on 1.7. There's slightly different philosophies in terms of how we upgrade versions. Azure Linux tends to stick to a major version and then only apply CVE patches for stability. And that's where you see some of the discrepancies. But once those pods get rescheduled, and just to show that, you'll see they're all running. You can come back, and the application's still up, and still running. I can go back to the admin page, go to orders, go to products, and everything's still loading. So that was the demo I had planned, Brian, after a couple of slides, but I started with that demo so folks can see how easy it is to get started with Azure Linux. It's just a one-line OS Sku property change in your infrastructure templates. You can also do it via portal. And B, you can run mixed node pools, so it's not one or the other. And your existing workloads will just continue to run without any changes. You built them with your Alpine containers, your language-specific containers, whatever it is.
Awesome. Yeah, and I appreciate you starting with the demo. And I think it certainly points to the fact that the promise of containers is that, hey, it works on my machine. So like I shouldn't care as a developer, at least, whether you're using Azure Linux or Ubuntu or whatever Linux distribution in Kubernetes. Obviously, the value probably matters more to the folks that really run the cluster that have to keep things up to date. And so I definitely want to hear more about what are the other sort of differences and benefits and comparisons of the two, which I know you're going to go through into some slides and some other demos. So if you want to go there next, that would be awesome.
Sure. And I'll actually, cherry pick the slides that I want to present here. If I can. Give me a second, sorry. There we go. Sorry, I just had to pick the monitor. And the way we'll do these is I'll talk a little bit about, what actually is in the operating system. So as folks are aware, this is AKS. It's a managed Kubernetes offering. And with Azure Linux, the worker nodes are actually running Azure Linux. Fun fact, as of just, very recently, the actual control plane that AKS manages for you recently also shifted over to Azure Linux. So the entire fleet of the AKS control plane is actually running Azure Linux as well, but customers, as is the case with AKS, don't need to worry about that. Our core is the Linux kernel. So this is one myth I want to knock out right up front. We're not building a a custom kernel. We take the upstream Linux kernel, and we actually do this for Ubuntu or any other Linux distro in Azure. We add drivers for the Azure host, and we do the same thing with Azure Linux, but it's just the upstream kernel. And for AKS, we trim some of the packages that would be in a general purpose distribution. So we have the luxury of getting rid of things like GUIs, text editors, stuff that you don't need, but would just add CVE burden for the platform engineer and maintainer. So we get rid of a lot of packages, so we have a very slim image. It's available everywhere. I talked about how we work on both the cloud and edge side. So if you're using AKS Hybrid or using AKS Cloud or even some of our IoT products which are running AKS, Azure Linux is the backbone for all of those. Furthermore, I think the AKS team recently announced a preview of both Kata, so kernel level isolation pods, so pods that can run with their own kernel level isolation, and confidential pods. All of those are only supported on Azure Linux. And a little bit of info on our update schedule, because this is a hotly asked question. We patch CVEs, critical ones, within 5 days. And apart from that, we release and follow the AKS weekly image upgrade process. And as far as compliance goes, we pass all level 1 CIS benchmarks, so we're the only distro that does that. And we have a fully serviced FIPS image. And I want to call out that all of this is free, so there's no extra licensing cost or anything to use Azure Linux. I did this demo, so I won't get into this slide. I do want to show that we have a partner ecosystem, because Kubernetes without the ecosystem of all the projects and companies that build great software is really nothing. So we have we make a conscious effort to work with all of these projects and companies to make sure that they support Azure Linux. It's for the most part trivial. So if there's new projects that come out, new ideas, they continue to seamlessly run on it because it is just Linux. But some of the ones that people are definitely using, Cilium, very popular with their networking stack, Istio, AKS is a managed Istio that's in preview right now, and a lot of the monitoring stack that folks are used to. So far I've painted a fairly great picture, but I'm sure people will ask, hey, there has to be some limitations, gotchas, that I need to watch out for, and there are, that I do want to make sure the audience is aware of. Upfront, there's a couple of GPU SKUs that we do not support. So we do support the V100 and T4 NVIDIA GPUs, and on our roadmap is support for H100 and A100. And for full transparency's sake, we technically have the CUDA drivers for this, but just like the whole world, there's a huge quota issue that we are running up against in order to do the testing needed to get this out the door. So that's really what's holding this up. For those who are familiar with AKS's upgrade channels, if you're using GPU SKUs on Azure Linux, we don't support the security patch channel. Unattended upgrades I won't talk about. Nobody should be on that. But if you are using security patch and you're using them with GPUs, just be aware that we don't support that right now.
What do you end up recommending for the at least just those VMs, the GPU SKUs?
Yeah, we recommend the node image option. So there, what that means is when you opt into those upgrades will upgrade the whole node. So you won't upgrade individual packages. And just digging into this briefly, this is primarily due to the CUDA driver and kernel mismatch that could happen if you upgrade one individual of the other. So we like it when people upgrade those together, and that's why we recommend the node image upgrade channel.
Makes sense.
The last one is the LTS. This is top of mind for folks because people are moving to 1.27 since 1.26 is nearing its end of life right now. We don't support this yet. I will say we're working really hard to get rid of this limitation, so I don't expect this to be here when 1.27 does go end of life. But today, if you go to the support page, you will see that, and I want to call that out.
Yeah, and the good news about LTS is like you're saying, I mean, for the first year of the LTS release, it's fully supported by Kubernetes, by upstream, by everything. So it's not too big of a deal. But certainly long term, hopefully it's not one of these limitations. But yeah, I I get it. We got to be completely accurate about it. So.
Yep. The last thing that's not on this slide, Brian, that I do want to touch on, because there are customers that do this, is people who are installing their own packages. So ideally in a managed Kubernetes, you don't want to muck around with the host. You want that to be managed by the cloud service provider. But some customers, for whatever reason, do make modifications to the host by installing packages. They may apply some syscontrols to change certain parameters. If you're doing things like that, I will say you need to watch out for those, because we are an RPM-based distribution, not Debian. So if you're taking a dependency on apt as your package manager and you're using daemon sets to pave all your nodes, there'll be gotchas there that you should naturally be aware of. But apart from that, these are the known limitations and challenges we've seen customers hit.
Awesome.
Performance is another topic that comes top of mind for people. So people always ask, hey, what are the performance benefits? And then can you share the numbers? And I want to caution the audience with this a little bit, because performance benchmarking is very relative. It can be dependent on the region, the SKUs, the applications that you use. In this diagram, I do share performance benchmarking across 3 things. So we do it every time we build a new image. We have synthetic clusters that we do performance benchmarks against, and then we have production clusters that we get data from. And where you see a green check mark is where we see Azure Linux being the best distribution on AKS in these. So when we do build time tests on a lot of the cluster create, upgrade, delete, Azure Linux is better. On synthetic and prod, we see slight benefit. What I will say is, as far as the other distributions, when we look at CPU network benchmarks, it's very much on par, because it's still the same kernel and containerd, and we're using systemd for the application lifecycle, and so those things will be on par. But where we do see benefits is where having a smaller image can benefit things like cluster creation, node start time. So I'll talk about another demo that I will play. In the first one, you saw me manually coordinating and draining node pools to move applications over. In public preview right now, we have a feature that was highly asked by a lot of internal and external customers that allows you to flip back and forth between OS Skus, so from Azure Linux to Ubuntu, or Ubuntu to Azure Linux, without needing to provision extra capacity. So what this will do is it treats it like an in-place upgrade, so like you're upgrading the node, but it will swap out the OS from Ubuntu to Azure Linux. Obviously, you want to test this before you just pave an entire fleet with this, but this definitely saves you a lot of capacity.
And I assume this takes into account all the typical AKS settings around that node and image upgrade, like max surge. It's respecting those kind of values. Obviously, PDBs happen anyway, but
exactly, and that's what a lot of people like about it is, I already have put a lot of thought into how we do upgrades, with PDBs and max surges, as you touched on. Just follow those things and upgrade the OS Sku for me, and that's exactly what this one does. So I'll go ahead and play this video, because if I did this manually, you'd have to sit through an upgrade. So we move it
nothing
over.
sounds more exciting than sitting through an upgrade. But
Yeah, it's a minute long, so I'll hit play.
audio.
To start with, we've deployed a cluster with a single system node pool with OS Sku Ubuntu. Let's go ahead and deploy a different template using the Managed Clusters API, where the OS Sku has been changed to Azure Linux. Once we deploy our template, AKS triggers a flow that's similar to node image upgrades. Skipping ahead a few minutes, we can see that the cluster is scaled up as defined by our surge capacity, and it's now draining work into our new Azure Linux node, then replacing the existing nodes one by one with a new OS Sku on the latest available OS image for that SKU. Skipping ahead a few more minutes. Once the migration is complete, the surge capacity is removed, and all the workloads have been moved over to the new OS Sku. It is also possible to trigger an OS Sku migration through the Agent Pools API. As you can see, we have a template here targeting the same node pool, except this time it's setting the OS Sku to Ubuntu. Once we deploy that, we can jump forward a few minutes and see that it's running a migration, switching each node over to an Ubuntu OS Sku instead. We're excited for our users to get their hands on this feature so that they're able to configure their existing node pools to use whichever OS Sku their needs call for.
Very cool. I mean, that certainly highlights the need to sort of configure applications in your AKS environment properly with proper health checks. We mentioned PDBs and Surge as he described in that, but with proper kind of health checks in there, and we're adding more into the upgrade process to make it smoother, to have like there's already a wait time or soak time that you can add so that yes, that node completes its upgrade, or at least in this case, its migration to the different Linux SKU, and it actually just waits. Let's just make sure that this actually runs correctly. One of the other things we're doing within AKS is we're adding metrics-based upgrades so that I could say, hey, look, it's not only important that it comes back up and ready, my workload, but it also meets these whatever criteria and thresholds of these metrics that we're measuring in our monitoring. So if its CPU spikes when you converted it, I don't see why it would, but if it did, we can actually stop the upgrade. And again, if it's a full cluster with lots of nodes in it, we've got functional nodes in the old model, and we can address everything or roll back if we need to.
Yeah, that's awesome. And actually, when you were talking about the CPU benchmarks and rolling back, one of the things that we do in partnership with you guys is those performance benchmarks. We run them on each release candidate. So sometimes we have actually stopped releases of new Azure Linux versions when we see that it regresses some of the performance benchmarks that we calculate on a release by release basis. Just as a in addition to customers doing all of this testing with their workloads, we should also do this before we release new nodes.
Yeah, awesome. Well, I think we covered a lot of the interesting things here. I'd love to actually talk about this all day. If people are listening to this video and they want to learn more, I mean, where's the most obvious place to go? Is there ongoing conversation? Is there places where I can go to keep up to date?
Yeah, and I will share the window with all of those details right now, actually. And
we'll add these links, of course, to the video, to the description. If people are looking down below in the YouTube description, we'll add all these links there too.
Yeah, and here's the best place to get started. It's a quick start. You can do the exact demo that I did. The places that we check most frequently where a lot of customers engage with us is on the AKS issues. So I want to point people to that. I also want to point people to the Mariner issues channel if you have any package requests, if you anything missing. We also do have Azure Linux monthly community calls. So if you want to follow this link, you want to join the community call there to drive that project forward, feel free to join that also. So those are the best places to engage with us and learn more about Azure Linux with AKS.
All right, very cool. I appreciate it. So that's all we have for now. Thank you so much to Danva for coming on and doing this. I wish the Toronto Maple Leafs success in the future. I really do hope they get that cup someday.
Hopefully in my lifetime. Cross my fingers. Thanks a lot, Brian, for having me.
Yep, thank you. See you folks later.